We often apply friction force without even realizing its need. Let me explain you with an example. So let's say we have this block placed on this rough surface for which coefficient of static friction is given. Now, if I ask you what is the friction force acting between these two surfaces, some of you would probably say that this is equal to mu s times normal force. But is that the correct answer? Let's try to find out. So mu s times normal is value of limiting friction, which is the maximum value of static friction acting between the two surfaces. But it may not be the actual value of friction force between the two surfaces. Like in this case, mg is acting in vertically downward direction and it is counterbalanced by the normal force which is acting in vertically upward direction. So there is no resultant force in vertical direction, and of course there is no external force acting on this block parallel to the horizontal surface. So that means there is no relative motion along the surface between these two surfaces, and if there is no relative motion between these two surfaces, then there would be no amount of friction force acting on these two surfaces, as friction opposes relative motion, and as there is no relative motion, no friction is required even though surface is rough. So this example suggests us that even though surface is rough, friction acts only when it is required.